Hi, everyone. We're going to take a look at ionic compounds with polyatomic ions, how to name them, and how to do formulas. They're a little bit harder than the binary. The main difference is we have subscripts, and then we also, in some cases, need parentheses. So we're going to start with the names. The one part that you absolutely need to have is your monatomic polyatomic ion sheet. Now, we worked with the monatomic in the binary. We're going to add on the polyatomic, which is at the bottom on the left hand of your monatomic polyatomic ion sheet. So remember, mono means one atom. So anytime we see one single element, that's where we're going with the monatomic chart. Anytime we see more than one, that's where we're going with poly. So to give you an example, lithium would be Li, that's a monatomic. Let's take acetate, it's CH3COO. Because there's more than one element, there's carbon, there's hydrogen, there's oxygen. We call it more than one, which is polyatomic, and all those are listed down below. So when we're naming them, the first thing is normally these are all one color. So I've broken them down into pink and black just so that you can see the two different parts. Just to let you know, a real easy trick is most of the polyatomics are the anions. There's only one that's a cation, which is ammonium, which is NH4. So first and foremost, if we look up K is potassium according to our monatomic list. If we look up ClO3, and do be careful with the ClOs, we have ClO, which is hypochlorite, ClO2, which is chlorite, ClO3, which is chlorate, and ClO4, which is perchlorate. Be careful because the subscript does matter when it comes time to the name. So if we look up ClO3 here on the left, it's chlorate, so this would be potassium chlorate as the name. Now our next one is Ca parentheses NO3 close them and 2. So the Ca is calcium, as you can see on the top. That would be from the monatomic ion sheet. The NO3, because it's a multiple atom, it would be from the polyatomic ion sheet, and NO3 is nitrate. Now just be careful, NO2 is nitrite, so not very much difference with those one letter, and it does matter that you get the letter right. The next one, this is our only positive polyatomic ion, and that's ammonium. So NH4 is ammonium. And then be careful because that I is by itself. So that's on the monatomic sheet, and that's going to be iodide. We still keep that ending of IDE. Okay, so when we go to make the formulas, we're going to do the easiest kind first. Same way that you did binary. We're going to write down the potassium first, which is K. We're going to write down the phosphate, PO4 minus 3. Okay, so you write down the charges, and then you cross them down just like we did in binary. The 1 we don't have to write because it's a 1. So you'll notice, like in our final formula down here at the bottom, I don't have a 1. And the 3 goes behind the K. Now, to make this a little bit more challenging, in some cases, we need parentheses to set the polyatomic ion different from the charge. And the charge carries to everything within that set of parentheses. So if we start with aluminum sulfate, we would write down aluminum. It's a +3 charge. We would write down sulfate, which is SO4, and it's a -2 charge. Now, nothing there cancels, so we're going to bring those down. The 2 goes behind the aluminum, and then to set that 3 charge separate from the SO4, we're going to add parentheses around the whole, the S, the O, and the 4, and put the 3, the pink 3 from the aluminum on the outside. So what this does is it tells us that we have 3 SO4 groups, which is 3 sulfate, and 4 times 3 is 12 oxygen in this formula, and then we would have 2 aluminum. Now, the reason we don't need parentheses on the aluminum is you only need it if it's a polyatomic ion, meaning more than one atom. So ammonium phosphide would show you if you need parentheses on the first part, which is the cation. So this would, again, ammonium's the only positive polyatomic ion that we're going to be working with. So it's NH4. Phosphide is a -3. So when I cross those down again, I want to put the ammonium in parentheses and bring the 3 from the phosphide behind it. Now, the reason I don't have a number behind the phosphide is that ammonium carries a +1 charge. So when it's brought down, we don't have to write it. The last one, these are always the ones that are the most missed for me. It's your hydroxide and cyanide, and that's because they don't have a charge at the end. So a lot of my students forget parentheses on these ones. Please don't forget the parentheses. So the first thing that you're going to do is you're going to list your magnesium. It carries a +2 charge, and then you're going to list your hydroxide. It carries a -1 charge. Cross those down and you get Mg parentheses, OH, close them, and then the 2 goes outside of the parentheses. Again, we're still doing the same thing. The difference is the OH and the cyanide and the hypochlorite, they don't have a subscript at the end of them, so it's not easy to notice that you need the parentheses. Now, the last thing that I want to talk about is with these ones, we do reduce. We haven't seen any of that so far. So if it's a 2 to 2, we would reduce down to 1 to 1. And if it's a 3 to 3, we would reduce down to 1 to 1. So what that looks like in an actual formula is this. We have strontium. It's a +2 charge. We have sulfate. Sorry, I didn't change the one there. It should be down a little bit. It's SO4 with a -2 charge. So I outlined the strontium. I made them in green so you could see the difference between the charges and the subscript. And then I outlined the strontium in pink and I outlined the sulfate in black, okay, so that we can see the difference. So when we cross these down, we would put parentheses around the SO4 and we bring the 2 behind. However, when you have the +2 and -2, just like we did with the binary or +3, -3, they cancel and we don't have to write them at all. A lot of my students like to cancel right at the very beginning. So they see the +2, -2, they just cancel those out and they go straight to the end. But I wanted to show you both ways. The other set of students, if you do bring them down, just watch that you don't reduce the 4 here. We always want the polyatomic ion to stay the same as when we started. So since we started with an SO4, we want to end with an SO4. The only difference would be the charges that we bring down. I hope this was helpful for the polyatomic ions and naming them and doing the formulas.